So, have you ever really stopped to think about what came before the Big Bang? It's got to be one of the biggest, most mind bending questions out there. Today, we're going to dive into Stephen Hawking's absolutely revolutionary idea for how the universe could have just popped into existence from, and I mean this literally, nothing. It's kind of wild to think that just over 100 years ago, we thought the universe was this calm, predictable clockwork machine that had just always been there. It was a nice, comfortable idea. But today, oh man, we know it's this incredible, expanding, epic story with a super violent opening scene. The shift in our understanding, it's been one of the greatest intellectual revolutions in all of human history for sure. And Stephen Hawking really framed this whole quest for knowledge perfectly with this quote. It's a journey that's really more about the excitement of the search than finding some final definitive answer. So to really appreciate where this journey has taken us, we first need to go back and see where it all started. Yeah, to really get how radical all this new stuff was, you gotta transport yourself back to the world before Einstein. At the turn of the 20th century, physicists were feeling pretty good about themselves. They thought they had a solid picture of the cosmos, one that was held together by this mysterious, invisible goo. They called it the ether. It was supposed to be the stuff that light waves traveled through, like sound travels through air. It all made perfect sense. It was neat and tidy, and it was completely, totally wrong. This whole beautiful idea was about to get absolutely shattered thanks to a now famous experiment and a young nobody patent clerk. And that young nobody patent clerk was, of course, Albert Einstein. In 1905, he published a few papers that didn't just poke holes in the idea of the ether. He took a giant eraser and just wiped it off the chalkboard of science completely. And while he was at it, he also got rid of the cozy idea of a single, universal clock ticking away for everyone, everywhere. This was his first revolution, special relativity. It totally rewrote the rules for space and time and gave us the most famous equation in history. It was a true masterpiece. But even Einstein knew something huge was still missing from the puzzle. His incredible new theory didn't have anything to say about gravity. So he spent the next 10 years wrestling with it, and he landed on a conclusion that, even today, sounds completely bonkers. He proposed that gravity isn't a force at all. Right? If it's not a force pulling me into my chair right now, then what in the world is it? His answer was general relativity. The idea is that massive things like the sun literally bend and warp the four-dimensional fabric of space-time around them. So planets, like Earth, aren't being pulled by the sun. No, they're just trying to travel in a straight line through this now curved space. The classic way to picture it is to imagine a bowling ball on a stretchy rubber sheet. It makes a big old dent. Now, if you roll a little marble nearby, it's going to circle around the bowling ball. Not because of some magic pull, but because the very shape of the sheet forces it to. That, Einstein said, is gravity. And this wasn't just some clever thought experiment. It got proven, and fast. In 1919, astronomers saw starlight literally bending around the sun during an eclipse, exactly like Einstein's math said it would. And this whole new way of thinking about gravity led to maybe the most profound discovery ever. The universe is expanding. And if everything is moving apart now, well, that can only mean one thing. In the past, it must have all been closer together. It must have had a beginning. But here's the twist. While general relativity gave us the Big Bang, it also created a massive new problem. The very theory that predicted the universe had a beginning couldn't actually describe that beginning. The logic is pretty straightforward when you think about it. Just run the movie of the universe in reverse. All the galaxies rush back towards each other, getting closer and closer and closer until everything, all the matter, all the energy is crushed into a single, infinitely hot, infinitely dense point, a singularity. This is the moment of creation. And right there, at that one single point, all our known laws of physics, including Einstein's own beautiful theory of general relativity, they just stop working. They completely break down. Science had led us right up to the edge of a beginning it couldn't explain. It hit a brick wall. So to smash through that wall, science had to bring in the other great pillar of modern physics, quantum mechanics, the unbelievably weird, fuzzy, probabilistic world of the super-duper small. Einstein, as you might know, famously hated the randomness that's at the very heart of quantum theory. He said, God does not play dice. But Stephen Hawking, he fully embraced it. He argued that all this quantum weirdness was actually the key to finally understanding the origin of everything. And this led Hawking to a truly mind-bending but incredibly powerful idea. He thought, what if, at the very, very beginning, time didn't behave like the era we're used to? He used a mathematical tool called imaginary time to explore this. Now stick with me here. It's basically a way of thinking where the line between time and space just dissolves. Time becomes just another direction, like up, down, left, or right. And here is the absolutely beautiful analogy he used. Think of the history of our universe in this imaginary time, like the surface of the Earth. Where does it begin? Well, it can start at the South Pole. But here's the thing. The South Pole is a totally normal, smooth starting point. The laws of geometry and physics work perfectly fine there. It's not a singularity. And crucially, you can't go south of the South Pole. The very concept doesn't make any sense. The boundary condition is that there is no boundary. So what does this no boundary proposal really mean? Well, the implications are just staggering. It paints a picture of a universe that is completely self-contained. It's a universe that doesn't need a creator, no outside spark to get it going. It just is, brought into existence entirely by the laws of science themselves. Okay, so that's the start. But how do we get from that perfectly smooth quantum beginning at the South Pole to the lumpy universe we see today, filled with galaxies and stars and, well, us? The answer comes from another quantum idea: multiple histories. It says the universe didn't just take one path from the beginning to now, it took every single possible path all at once. The reason we see the universe we do is that we, by the simple fact that we exist to observe it, find ourselves in one of the histories that was stable enough for stars to form and for life to eventually evolve. And what's amazing is that when you look at the most probable of these life-friendly histories, they all share a common feature: a moment right at the beginning of insane, hyper-fast expansion called inflation. This smoothed everything out, but also left behind these tiny little quantum ripples in the fabric of space-time. And those little ripples, they were everything. They were the tiny differences in density that gravity could grab onto, the seeds that over billions and billions of years grew into the giant cosmic web of galaxies we see all around us. And the best part? We can actually see them. Satellites have taken a baby picture of the universe, and we can see the faint imprint of those very first seeds. Which brings us right back around to Hamlet. That tiny, smooth, self-contained quantum beginning, that nutshell, it held within it the complete and total blueprint for the infinite space we call home. And all this leaves us with one final, absolutely mind-melting thought to ponder. We live in one of the histories that was just right for life. But what about all those other possible histories? If our universe is just one of many possibilities allowed by the laws of physics, what kinds of strange, alien, and unimaginable universes might be out there? What do you think they'd look like?